Next, we have theorem 1.2. It says that let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. So now before that, you should know what is a rational number and an irrational number. I hope you already know what is a rational number. Any number which can be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0, we call them rational numbers. Now what about irrational numbers? The same, but what we have to say, a number is called irrational number if it cannot be represented in the form of P by Q. Okay, if it cannot be represented in the form of P by Q, where P and Q are integers and Q is not equal to 0, is called irrational numbers. So the examples of irrational numbers are root 2, root 3, root 5, pi, minus root 2 by root 3, etc. So these are some of the examples of irrational numbers. Okay. Now coming back to the theorem. Okay, this is related to the previous theorem we already know. Okay, that's about the prime factorization and its uniqueness. Now, here what are we saying? Okay, here we have P, which is a prime number. If P divides A square, then P divides A, where A is a positive integer. Okay, let P be a prime number. Suppose P is a prime number. Let's just take one prime number 3. If 3 divides A square, okay, so we have 9, which is A square is equal to 9. So if P divides 9, so if 3 obviously it divides 9, then P is also divisible by A. That means the square root of 9 is 3. So 3 is also divisible by 3 itself. That is also fine. If it is divisible by A, it is divisible by A square, it can also divide A. That's our theorem, where A is a positive integer. Okay. So the proof is also given. So what we are doing is we are just prime factorization. Okay. Where A is represented in the form of P1 into P2 into P3 into etc. up to Pn. Where this P1, P2 etc. are prime numbers, and this expression is unique. It's a prime factorization. Now again we are writing A square, so that means we have to multiply these factors twice. So P1 into P2 etc. up to Pn into P1 into P2 etc. up to Pn. So this will give us P1 square into P2 square into P3 square etc. up to Pn square. Now the only prime factors of A square are P1, P2 etc. up to Pn, and also if you look at A also it's the same factors. So obviously if P is dividing A square, then it also have the common factors with A. So obviously P should also divide A. So that's about our theorem. Now theorem 1.3. So this kind of questions can be asked in exams. It's very common and very important. So what you can do is you can follow the structure. So these things we know by common sense, but what we need to do here is we have to use the theorem and we have to follow the steps and show how root 2 is irrational. So theorem 1.3 says that root 2 is irrational. So we are just finding the proof. Obviously the first step is to assume the contrary. So what we are using is we are assuming that root 2 is rational. Okay. So if root 2 is rational, we are assuming there are two integers. So let R and S be integers which are not equal to 0. Then how can we write root 2? Then root 2 will be equal to R by S. Okay, we can represent, if it is a rational number, we can represent it in the form of R by S, where S is not equal to 0 and R is not equal to 0. Now, suppose R and S have a common factor other than 1. So if they have a common factor other than 1, so then we decide the common factor, let's say root 2 is equal to A by B, where A and B are coprime. Okay. So suppose R and S have a common factor other than 1. Then we decide by the common factor to get root 2 is equal to A by B. So from this what we get? B root 2 is equal to A. Okay. Now squaring on both sides. We are going to square on both sides. So what we get? 2B square is equal to A square. So this is what we get on squaring both sides. So this means here 2B square is equal to A square. That means 2 can divide A, right? 2 divides A square. So we write 2 divides A square. So we can also say that 2 divides A by theorem. Theorem 1.3. So if 2 divides A, now we can write it as A is equal to 2C. Okay, if 2 divides A, we can say something multiplied with 2 we get A. Okay, C is an integer, any integer. Okay, when we multiply 2 with C, we will get A. Why? 2 divides A. So that means A is divided by 2, we get C. Okay, that's the concept. So we can write it as A equal to 2C. So now, if A is equal to 2C, for some integer, let's say C, by substituting for A, we already have. So we are substituting for A, we get what we have A here. Here we have A is equal to B root 2. So if we substitute A in this equation, what you will get? 2B square is equal to 2C the whole square. 2C the whole square is 4C square. So that means B square is equal to 2C square. So here what we are getting? We are getting 2 divides B square, then 2 divides B. So if you see here, we are getting a contradiction. A and B have at least 2 as the common factor. right? But we took A and B as a coprime. Coprime means they will only have one as their common factor. There will not be any other common factor. But what are we getting here? We are getting 2 divides B, and also we are getting 2 divides A. So that means A and B should have 2 as their common factor. At least 2 as common factor. But what, this is a contradiction to the, we already consider A and B to be coprime, but what we are getting is they have common factors. So this is contradicts the fact that A and B have no common factors other than 1. So our assumption that root 2 is rational is wrong. So root 2 is irrational. This contradicts our assumption. Okay, assumption that A and B are coprime. So root 2 is irrational. Okay, I will guide you through the steps once more. So what we did is we first assumed R and S. First we are assuming the contrary, that is root 2 is rational number. If it is a rational number, we can represent root 2 in the form of P by Q, where P and Q are integers and Q is not equal to 0. Like that, we are choosing R and S, where R and S are integers and S is not equal to 0. So we wrote root 2 as R by S. Now, R and S have a common factor other than 1. So we cannot say they are coprime. But now what we are doing is we are assuming two numbers A and B which are coprime. Coprime means we only have one as the common factor. There will not be any other common factor. So then we are writing root 2 is equal to A by B, where A and B are coprime. So B root 2 is equal to A. Now we are squaring on both sides. So we will get 2B square is equal to A square. So this means that here 2 divides A, right? We can write it as B square is equal to A square by 2. So that means 2 divides A square. So that by theorem we can say that 2 divides A also. Now we are assuming another integer C, where we can write A is equal to 2C. Since A is divided by 2, we are getting an integer C. Okay, so A is equal to 2C. Now we are substituting in the previous equations. So we will get 2B square is equal to 4C square. So we get B square is equal to 2C square. So here we are getting 2 divides B square. But by theorem we can also write that 2 divides B. So if you see 2 divides B and also 2 divides A. So these are two statements here. But we assume A and B to be coprime. So they will only have one as the common factor. But here we are getting 2 as another factor, common factor. So our assumption is wrong. So root 2 is irrational. I hope it's clear. So we are going to follow the same steps or the structure for the other questions. The next question is to prove that root 3 is irrational. So like any other question, what we have to assume here is, if you want, you can continue with the R and S. It's not that necessary. So what you can do is you can start from A and B itself. So, okay. First things first, we are assuming the root 3 to be rational number. So let's assume that root 3 is rational. Okay, if root 3 is rational, then we have A and B are integers which are not equal to 0. Okay, so then we can write root 3 is equal to A by B. Okay, it's a rational number, so we can write it in the form of P by Q. Now, here we are not mentioning A and B to be coprime. So we are going to mention that in the next step. So suppose A and B have a common factor other than 1. So then we can divide by the common factor and assume that A and B are coprime. A and B are coprime. Now coprime means they only have 1 as their common factor. So now we are writing, so B root 3 is equal to A. So now squaring on both sides, what we are getting? We are getting, okay, 3B square is equal to A square. So here what we can say, A square is divided by 3, or we can say 3 divides A square. That means 3 divides A by theorem. 1.3. Okay, now there is another integer C. So A is equal to 3C. Why we are writing A is equal to 3C? Because A is divided by 3. So we are getting another integer C. Okay, so this is like C is equal to A divided by 3. So when A is divided by 3, we are getting another integer C. So A is equal to 3C for some integer C. Okay, now we are substituting the value of A. Substituting value of A. What we are getting? We get here in the place of A we have to substitute 3C. So 3B square is equal to 3C the whole square. So that means 9C square. So we can write, which implies this is B square is equal to 3C square. So what we are getting here, we are getting 3 divides B square. So we can write 3 divides B square. So that means 3 divides B. So if 3 divides B square and 3 divides B by theorem, now what we can say? So that means 3 is a common factor between A and B, right? A is also divisible by 3 and 3 is also divisible by 3. So we can say that, therefore, A and B have at least 3 as a common factor. So if 3 is the common factor, it contradicts our assumption that A and B is a coprime and B are coprime. So we can say that this contradicts that A and B are coprime. So if this means that our assumption that root 3 is rational is incorrect or wrong. So our assumption is wrong. Hence, root 3 is irrational. So basically what we are doing is we are assuming something to be rational, then we are proving ourselves that it's an irrational number. Okay, so I hope this is clear for you. The structure is that first we assume root 3 to be rational number. Then we take two integers a and b. Okay. Okay, we represent root 3 in the form of a and b as a rational number. Okay, so a by b, where a and b are not 0 and they are integers. So now the next step what we are assuming is let a and b be co-primes. If they are having any common factors, we are dividing it and making it co-prime. Okay, so now a and b are co-prime, so we are representing root 3 as a by b, and so we get b root 3 is equal to a. Now we square them and we get 3b square is equal to a square. Then we are getting that 3 divides a square and then 3 divides a by theorem. Now again we are considering some integer c where a is equal to 3c. Since 3 divides a, we can write a is there are some integers c such that a is equal to 3c. Okay, now we are substituting this in the first equation. Then we will get 3b square is equal to 9c square. So when we cancel out the 3, we will get b square is equal to 3c square. But here we are getting that this particular b square is divided by 3. So that means 3 can also divide b. So that means a and b have a common factor. They are not co-prime. So this is against our assumption. So root 3 is irrational. So that's about this question. I hope it's clear.